I'm going to tell you a few stories. I used to be a consultant, and I had customers, luckily. And some of these customers told me stories about their problems. And I want to tell you these problems because they are relevant to the case. One of these customers was a steel foundry, a large factory. They had a huge data collection place. Basically, in their factory there was a place where they made the steel flat. It was long, a couple of kilometers, and every meter they had a collection point of data to see how was the steel in that precise moment. So they used MySQL to collect the data, and as you can imagine, having a factory that is working full-time, this database was getting data very fast, and the data was growing very fast. So the slaves were lagging behind. The problem is that if you have a master that can keep up with the data and gets the data in time, many parallel transactions, then when you replicate the data, it goes to the slave, and the transaction, instead of being one next to each other, they are one after each other. So eventually it has lag. So this was the first story. The second story is the story of a shoemaker, not the one who runs in Formula 1 and became world champion. Is somebody who makes shoes. You know, in Italy, Italy is famous for shoemakers. So this person was very successful. He sold shoes everywhere. He had many shops, and he had headquarters in Milan. And he wanted the opposite of what replication does. So instead of having one master in headquarters that sends data to the branches in the shops, he wants all the shops at once to send data to headquarters. So he wants something like this that MySQL cannot do. You have many masters and only one slave. And the third story is about a widget seller. You know, these ringtones and things like that that are very popular. There are people who actually make them. They don't come up from the sky. Since there are many users who want to buy them. So he made a successful business, and the business was distributed, so he wanted to insert data from many places instead of inserting data from one master only. So basically he wanted something like that. He wanted to have a place where everything worked by default. So he had many nodes, and he wanted all the nodes to be masters. So the gist of all the stories is this. It's a nice wish, but MySQL cannot do that. So native MySQL replication cannot do what those people want. And I've been working with replication for quite a long time, so I remember very vividly that this was a problem that I was not able to solve with normal means. So I had either to invent a workaround or tell them, sorry, we can't do that. And now, finally, I'm working with a project that makes this dreams come true. What is this tungsten replicator that by chance is the same thing that you see on my t-shirt and on the t-shirt of my colleagues sparse around the conference. It's one open source project, and you can find it in Google Code. You can get the source code, you can get the binaries. It's completely open source, 100% is released under the GPL version 2. So what can we do with the tungsten replicator? A lot of things, including the solution for those dreams. One thing that you can do, that was not among the dreams but it comes handy, is a easy failover. You can instantiate multiple masters. You can have multiple masters replicated to a single slave. And you can do parallel replication. In addition to that, you can also replicate it to Oracle and to Postgres, thanks to my colleague Linas Virbalas, who is here. He's the shortest one. Please stand up, Linas. Yes. So he's the one who made this possible. We can replicate not only from MySQL to MySQL, but from MySQL to Oracle and to PostgreSQL, using as a departing point the binary logs of MySQL and replicate to Oracle. And now there is also something that he will show tomorrow. He managed to do PostgreSQL replication from PostgreSQL. So eventually we are close to have a very mixed environment where we can replicate from anything to anything. And also today we are trying to do a replication from MySQL to MongoDB, but this is something that you will see in the afternoon. Now let's see from the beginning what we can do with Tungsten. Tungsten is different from native MySQL replication. Native MySQL replication is a simple thing where you instantiate a service that you say start and stop. There is no complications. But since Tungsten Replicator does a lot of things more, then you have to instantiate something more complex, a little bit. So the concept is, if you want to start replication, you install a service. And a service is for each stream of replication that you want to create. In the case of normal master-slave replication, you just have one service, and this is how Tungsten imitates native MySQL replication. So this, if you use Tungsten only for master-slave, you are doing something that is slightly more complex than MySQL native replication, but in addition you have the ability of doing easy failover. How does the failover work with a Tungsten replication system? Now, if you don't know about the problem, the failover in MySQL is complicated because MySQL doesn't have a global transaction ID system. So, if you have a master that caches, you promote one slave to master, you promote the most advanced slave to master, and then you have to figure out which transactions are missing from the other slaves and get those transactions from the master that you have just promoted. Which is feasible, can be done, but it requires some manual labor because the transactions that are in the slave that are promoted may be in a different position from the initial binary log from the master. So you don't know by looking at the records in the slaves where to start the recovery of the missing records from the new master. And it's a bit of a pain. So there are tools that help you to do this, but in general it's a manual operation. Now let's see how you do a switch of the master in Tungsten. So in a normal situation you have client updates that go to the master and everything is running smoothly. When you want to do a prepared switch, you just stop updating the master and then you wait until the slaves catch up with all the transactions that were inserted in the master until that moment. Then you can stop the replicator in the slaves and in the master, and then you have stopped the replication completely. What you do now, you instruct the candidate new master that is going to be the master from now on. You tell the old master you are going to be a slave, and you give the coordinate for the new master, and you tell the remaining slaves, look, the new master is that one. Then you switch on the master, you switch on the slaves, and you tell the clients to go to the new master. Everything you can do from a single position, so you don't have to log into several places to do this operation. You can direct everything from a single server. Now, let's see a demo. Yes. I connected to a couple of servers that I have in Germany. And I'm going to install a master-slave topology without parallel replication. So the simplest thing that you can do. Now, the system is installing tungsten in 4 servers. First of all, we test the system to see if it's working. So I'm going to install 100,000 records in the master, and I see that the 100,000 records come to all the slaves. So it's working. Now we do the operation that I've shown you in the slides. So we tell all the nodes to stop. So I put I did that in the wrong sequence. I should have done the slaves first, but anyway. Okay. I often make mistakes. Okay, now let's put first the slaves offline. And then the master offline. Now I tell slave 2 that is going to become the master. Set role minus role master. Now I tell slave node 1 that was the master, that is going to be a slave, and the address of the new master, which is R2. And I do the same for slave number 3. Now, I'm going to make a deliberate mistake, and I forget to do the same operation for slave number 4 and see what happens. Okay, remember about this mistake. Now I put everything online. and then I ask everything if they are online. Everything is online. Now, I'm going to send a record to the new master and try to retrieve the record from the slaves. So the host is now R2. And I created this table. And now I'm going to ask all the slaves, what do they have? And you see, the master and all the slaves have this new table. But you remember I made a mistake. So, while this removed, let me explain what happened. What happened is what I call master-slave with an attitude. The thing is, since tungsten has a global transaction ID, it has the possibility of becoming a relay slave always. So if this number 4 asks number 2 for data, it will get the data even if that is not a master. Actually, in this case, the figure should have been from 1 to 4. So number 4 is still replicating from alpha, and alpha in the new configuration has become a slave. But he will get the data because alpha will get the data from Bravo, and he will be able to replicate the data to somebody who asks for that. Please.
And how the number 4 knows that there is a new data? It pulls the data?
It pulls the data, yes.
How it knows if there is a new data, if the master now is number 2, right? But it doesn't know that number 4 is his slave. How does it know that it needs to push new data, or number 2 or number 4 knows how to, there's new data?
Number 4 knows only, as we saw, it was still asking number 1. Remember, because I made a mistake.
Okay.
So number 1 has received data from number 2, so it writes in its table of available global transaction IDs that the latest ID is that one. Actually, you can get the information directly from replicator to replicator. You don't have to look at that table, but you can see that on your own if you want to look. So the replicator talk to each other, and they say number 4 asks to its master, which believes is number 1. What is the latest? And that one, even though it's not a master, but it's a relay slave, says the latest is number 1200. And he said, I don't have 1200, send it. So, even though it's not a proper master, he will be able to send the data because it has it. So when you replicate using tungsten, every node will have a full copy of the data. So, parallel replication. The dream of the foundry owner. We have a single apply, and to do parallel replication in tungsten, the only thing you have to do is to say From now on, I want many channels. It's as simple as that. So you do the normal replication, you just add one parameter, the number of channels that you want, and these channels are going to be applied in parallel. Now, how parallel replication works? It's not a solution that works for everybody. It's sharded by databases. So if you have a single database, this is not for you. If you have lag problems, then this is something that solves your problem very easy, very nicely. If you cannot split your data across several databases, then unfortunately you cannot help you.
Is that shard across in tungsten? Sharded by database, does it apply to tungsten or to MySQL 5.6?
This is tungsten.
Okay, so it applies to both.
I mean, 5.6 did the
No,
same.
in 5.6 they also shard by database. That's
Yes.
why I asked. Okay, and how do you handle transactions that covers multiple databases?
Okay, so if there is a transaction that spans multiple databases, Tungsten can detect that and will serialize everything until the end of that transaction. So if there is a transaction that goes across databases, Tungsten is not able to determine if applying that transaction is safe or not. So just to be safe, you will say, okay, until this is finished, I will not parallelize anything. At the end of that, I will resume parallelization.
I think this is also what MySQL does.
Okay.
I'm not sure, but I think this is also what MySQL does.
I heard that this is in the plans, but I'm not sure that they managed to do that nicely.
Ah, okay, so they don't handle that at all?
They want to do that, but I haven't seen that in the prototype. Maybe there was some parameter that I missed, but okay, eventually it will manage. So why do we have slave lagging? The main problem that we have is that you may have a complex query in the master. This applies only to row-based replication, statement-based replication. So if you have a complex query in the master, when the query goes to the slave has to run the same query and it lags behind. Or you can have a DDL, meaning the alter table that runs for hours. And if you have this, replication is stopped until the DDL is finished. Or you have a slave restart, you do some maintenance, then you restart the slave after 6 hours, and the slave has to catch up. So in all these cases, parallel replication can help you. We did some tests of parallel replication. For the record, there is a generous sponsor who is paying us to develop parallel replication. So we have prepared some detailed QA for them, and so far they are satisfied with the prototype that we have produced. And what do we do to simulate what this very powerful sponsor hosts are producing? We take a lot of databases, and on each one of them we run sysbench with many parallel processing. So in this way we produce a binary log where there are many transactions side to side. Then we save the binary logs in one folder, and we start the simulation this way. On one side we put one slave with regular replication, and on the other side we put a slave with tungsten replication. So when we start the test, we will have the relay logs, the slave that is reading from the relay logs and apply with a single thread, because normal replication has a single thread. And on the other slave, we will have tungsten that is reading from the relay logs and applying in parallel to MySQL. So there is a test where I had something like 2 hours of sysbench that produced binary logs that the native replication can catch up in almost 1 hour. And the same thing with the tungsten parallel replication was in 25 minutes. Now, this powerful sponsor that I mentioned before has probably better machines than we do. They report that in their tests they have even better times than this, meaning that for 1 hour of native replication they get the job done in 20 minutes. So there is still some optimization to be done, but this is pretty good. It means that you have your slave available in half the time or 1/3 of the time, depending on how fast is your hardware and how well is your database tuned. More questions so far? Okay, let's see the other dream, multi-master. So the recipe tungsten to have multi-master is to use more services. If you want to do bidirectional replication, instead of using one service, you use 2. So in the first service, you have a master service in alpha and a slave service in Bravo with a service named alpha. For the service named Bravo, you have the master in Bravo and the slave in alpha. In this way, you have 2 independent streams of data. Now, you know probably that you can do the same thing with MySQL, with native replication. The same caveats that you do in MySQL apply here. If you update both masters at once, either you know what you are doing or you run into trouble. If you have a rule that says you apply only master A and you don't apply, you don't update master B, you are safe. If you want to update all of them at once, you must have some rules. For instance, you say master A can only replicate tables A, B, C, D, and master B can only replicate table X, Y, and Z. If you do something like that, you avoid conflicts. If you let the masters apply data to all the tables, you will have conflicts, and so far there is no way of avoiding conflicts. Tungsten has filters, so using filters you can say, you can enforce this kind of rules. You can say, don't apply to alpha data coming from Bravo in tables A, B, C, D. You can say that. So you can avoid a conflict. But if you have more complex rules, like only a few users can update things in one master or the other, that I'm not sure that you can do with the filters. But anyway, the gist of the problem is that you are responsible for the conflicts. You are responsible for avoiding the conflicts. You can use the same design to do a system that survives a disaster. You know, with replication, you can have a standby slave that is ready to replace the master in case of a disaster. But the disaster should be local. So if you have a master and a slave in the same place, and the disaster is, let's say, flood or an earthquake, fire in the building, you will lose the master and the slaves at once. So you need to have something that is in a different location to survive a real disaster. And this is how our customers do use tungsten for disaster recovery, or to be fault tolerant in case of this kind of disasters. You have a master slave in two different locations, and the two masters talk to each other to make sure that they are always up to date. So if Atlanta collapses, Boston takes over, and the other way around. And using the same recipe, you can do through multiple masters. But before seeing that, let's see the other dream, the dream of multi-source. Multi-source means many masters replicated to one slave. How do we do that? Many services. So, look at this. You have 3 masters and you want to replicate to the same slave. So you instantiate 3 services. Service alpha in the host alpha, service bravo in the host bravo, and service Charlie in the host Charlie. And for each one of these services, you instantiate a corresponding slave in delta. So delta will have 3 services receiving data from 3 sources. What is the problem here? The same that I mentioned before. If you are not, if you don't make sure that you get different data from the 3 masters, then you can have trouble. The problem of the shoemaker was that he had several shops that wanted to send different data to the headquarters. In this case, there is no conflict because the shops are different. So the data that is in one shop is different from or is separated from the data from the next shop. So in cases like that, it's easy to avoid conflicts, and you can do that. The difference with MySQL native replication is that you cannot do that with MySQL, but you can do that with Tungsten. Let's see a quick example. So we do a multiple source topology where we have 3 masters and 1 slave. So you see here master and then master which is Bravo, and then master Charlie. And then you see 3 slave services instantiated by Delta. Now, let's try to see how it works. We send 100,000 records from each master.
Someone's stuck in a puzzle. Check it out.
Hello? Okay, so each master has sent 100,000 records and the slave has received 300,000 records in 3 different tables. So this is how multiple source should work. So the recipe is simple. You have several services that go to one place. And seeing this picture, you can figure out how you solve the dream of multiple masters. You just put many services in each node. So this is what you do for 3 masters. Every node is a master, and every node as the corresponding slaves for the 2 other nodes. Using the same recipe, you can do 4 nodes. For 5 nodes, it's going to be more complicated, and for 6 nodes, even more. We are working at a system to simplify things, but even for the moment, this works. And contrary to MySQL native replication, it does work, so it is possible. In MySQL replication, the only thing you can do is a ring topology. And the ring topology means that if one node fails, replication stops, so it doesn't flow anymore. Instead, here, if one node fails, you can still go around and exchange data in the remaining nodes. So it works like that. You start inserting data in one master, and it goes to the other three nodes. Insert in another node, and it goes in all directions, and so on, until you have a full flow everywhere. So, what can you do this with Tungsten? You have to install Tungsten, of course. You have to get the binaries, expand the tarball, and run one thing that is called Tungsten installer. This is something new that we have done recently, because before then you had to run 2 commands that are quite complicated, and you had to answer a lot of questions, and before answering the question you had to read the manual and make sure that you were compliant with all the prerequisites, which is a long process. So after a few months of QA and refactoring, we have a single command that does everything that I've mentioned before. So this command will check that you have all the prerequisites. If you don't have the prerequisite, it tells you exactly what is missing, and then you can fix it. Eventually, it will tell you, okay, you have all the prerequisites, I'm installing what you have asked. And what you have asked could be 2 things. Either I want to install one node, or I want to install a cluster. So you can say, with a single command, I want to install master in node 1 and slaves in node 2, 3, 4, and you can do that with a single command. So if you have a user that is allowed to SSH from node to node, the installer will do all the work for you. So we will check that all 4 nodes have the prerequisites. If they have the prerequisites, it will start the installation in the master, and then it will do the same thing for the slaves, and eventually bring you coffee. No, not yet. That will be for version 3. Tools. You have one tool that is called Replicator. This is the service provider. So you can start and stop the service using this tool. It doesn't do much except starting and stopping the service. What does things is this T-Rep CTL you have seen me using during the demo. It's Tungsten Replicator Controller. Is what you can use to do mostly everything. So you can do things like putting the replicator online, offline. You can change the role. You can get statistics of on what the replicator is doing. You can see exactly what the parallel replication is doing in a particular node, up to the tiny details if you really want to. It will be too long to explain what it does, but I am available to answer questions if you want to know more. And then we have a THL. THL stands for Transaction History List. This is corresponding to, more or less, to MySQL bin log, but with more details that you can get from compared to MySQL bin log. It gives you access to the Tungsten relay logs, and you can get very precise information on every transaction, including where the transaction comes from. And then one slide with advertising. We are hiring. If somebody wants a job with the contingent, please talk to me. We are listening. No hands yet? Okay. So that's it. We are open for business and open for contribution. So if you want to see the open source tungsten, this is in Google Code, and if you need some business information, we have that as well. So on top of the open source tungsten, you have a service that is called Tungsten Enterprise that does most of the replication stuff automatically and without manual intervention. Of course, this is not free. And thank you for listening.
Thank you.